So today we're getting back to Polkadot, and we're going to talk about consensus, a brief overview. So if you're familiar with blockchain technology, you know that there are two very common ways of consensus, of obtaining consensus. You have proof of work, which is Bitcoin, which means you run an algorithm to try to find a number or a hash that is a certain level. You know, they make it harder and harder, and you know, when the first validator or node that gets the correct number, they get to make the block. And the second is proof of stake. So your claim on getting to make the block is a function of how much you've staked. And generally on proof of stake, you need something to go with it to finalize the chain, and a separate algorithm. So there's two types of, two concepts that you have to understand in terms of consensus. With provable finality, once the state of the chain is agreed to, it cannot be reversed. Probabilistic finality is a little bit different. We estimate the probability that the block is final, and the advantage there is you can't get stalled. The block is always able to be produced. And but Polkadot uses what they call hybrid consensus. So what is done in Polkadot is the block building is separated from the finality. And the block building is done by Babe. And Babe stands for blind assignment to the blockchain. So it uses the stake, so it uses like proof of stake and randomness to determine whether a validator gets to produce a block. So it's probabilistic, which means you can always produce a block. It's not going to get stalled. It's also not vulnerable for like a 51% attack, which is something that you can see in Bitcoin. The Bitcoin algorithm, if some entity had control of 51% of the processing power on the chain, they can essentially take it over. But since it's probabilistic, and you use probability and randomness, that's not the case with Babe. Now, Grandpa is the finalizer, and it stands for Ghost-Based Recursive Ancestor-Deriving Preset Agreement. That's a pretty big mouthful there. Basically, instead of agreeing on the block, it agrees on the chain. So if 2/3 of the validators agree on the chain, then that will be the chain. Now, the way that is done is a function of primary and secondary blocks. Primary blocks are those that are produced by selected validator. Secondary blocks, if no validator is selected, none of them get enough. Kind of like you get into a runoff situation, right? No candidate gets enough votes to get the seat. So it is with this. And when that's the case, what they do is they use a round robin type algorithm to determine. And those blocks that are selected that way become secondary blocks. So the chain that is selected is the they have to be brought together, and the way the Grandpa Babe is brought together is the chains if the chain that's selected is the one with the most primary blocks, which may not be the longest one. So suppose you have a chain that has 10 blocks, and 2 of them are primary, and 8 of them are secondary. And you have another chain that's 5 blocks, but all 5 of them are primary. That's the chain that's going to be selected. And that's the chain that they will build blocks on. There's another concept before I end that we're going to need to go into a bit more depth, because it looking at the material. This material is based on the Polkadot wiki. Looking at it, it's a bit complex. So, but you know, the concept is verifiable random function. So the random function is not just, rand that we're used to. It takes an input and produces a random number with authenticity, that the random number is generated by the submitter. So it has to, in essence, not just produce a random number, but prove that the random number was generated by the submitter. So that I definitely want to get into that a little bit more, because that is an interesting a new concept to me. And I think what I want to do is try to find an example of such an algorithm, or create, get enough information in details that I can write such an algorithm, so I can actually show you all what that means, or what is this authenticity, right? So we're going to get a bit more into that. But to sum up, basically in Polkadot, you, instead of having something like Bitcoin where you have, yes, we prove this, this is a, it's a provable, it's a chain that once it's made, it can't be changed, but it takes insane amount of computing power to do it. And it can theoretically get stalled, and it's not, probabilistic, which means, you don't know, you don't have 100% finality. You get to maybe an eventual finality, and it can take a long time. So that's the negative with the probabilistic method. So both of those separately have negative traits. What they do in Polkadot is they say, okay, what's the issue with provable finality that can't be changed? Well, the issue is you may not be able to produce blocks. So to produce the blocks using the Babe algorithm, they use a probabilistic approach, which means that it can't get stalled. And you can see it's kind of almost like an election, right? We had the Senate elections, and then we had runoffs. So none of the candidates can get to the required 50%. So then you had to have a runoff. In this case, it's not a runoff where, the same type of method is used. It's a round robin type approach. And And they combine that with Grandpa, which has the finalizer. It does determines what is the final state of the chain. Remember, we spoke about the concept of state machines, and we think about blockchains as a infinite state machine. It is a state machine. You go from state 1A to state B, et cetera, but unlike something like a traffic light as a state machine, or baseball, which was the example we gave, base paths, in blockchain, it's infinite. But you have to still determine what the state of the chain is. And that's where these algorithms come in. And, various methods have their pros and cons. But I am intrigued again by this verifiable random function. So this is just an overview. There's definitely a lot more to dig into here. And, but I think want to get to some hands-on, look at something type stuff. So I think over the weekend, we're going to look at actually installing some of that code from GitHub that we looked at the other day. So hopefully this has been interesting to you, and I will speak to you next time. If you like this, please give me a like. If you want to see more of these, subscribe. You'll get notified, of course, when a new video comes out. And take care, and speak to you next time.